All right, good morning, everyone. Yes, my name is Johan Stokking. As Lucas said, tech lead and co-founder of the Things Network. First I would like to say thanks, Lucas, so much for organizing this and the team. This is really great. I said this morning to Thomas, who I'm traveling here with and speaking later today, that we really started something 3 years ago and that we also didn't actually know what we started, but it's really, really cool and exciting to see that. So I'm going to talk a little bit about the Things Network, about our history, what we did, why we do it, and also our next steps in the network and in the community, and engaging with business deployments as well as governmental deployments. But first I want to talk a little bit about the technology. And the Things Network is all about using LoRa and LoRaWAN actually. And LoRa is designed really for Internet of Things. And it sounds super obvious, but I think it's really important to mention that always, because many wireless technologies that we use today for IoT are actually not designed for things. So for example, Wi-Fi, Bluetooth, cellular, originally they're designed for human interaction. And that's fine, they are perfect for that. They have high bandwidth, they are super powerful, but they also cost a lot of power. And if you use these technologies for sensors that you stick somewhere in a city, then you run into range issues, you run into power issues quite quickly. And for that you need a technology that is really designed for IoT. And LoRa is that. And another super nice thing about LoRa is that it's designed for use in the ISM bands, so you don't need a license and everyone can set up a network. LoRa is also very high capacity, and that means that you can place essentially as many gateways as you need to cover a deployment. There is no pairing with a certain gateway, there is no handover between gateways. Gateways are completely transparent, and so if you need coverage somewhere, you just place a gateway, and that's essentially all you need to do. And that also makes deployments easier and cheaper. It's low power, low bandwidth, so yeah, you can't send a lot of data over LoRaWAN. Most devices are often in deep sleep. It's not necessary. We also see, for example, street light solutions where you obviously have access to power supply to turn on the light. But most sensors, they sleep most of the time and they wake up to send a message. And that means that devices can actually run for months or years on batteries, or even completely autonomous on solar panels. A little bit about the RF side, just high-level coverage, because it's important. LoRa uses so-called spread spectrum modulation, and that means that there are basically two ways to communicate through the air. One is using a narrowband waveform. It's essentially putting quite some energy on a single frequency, and that is very useful, for example, if you control the spectrum. So if you have a license on a spectrum, telecom operators do. If you don't have a license, then this is not going to work for long-range communication, and you need something else. And LoRa uses spread spectrum, so there's a center frequency and the data is spread around that center frequency. And if you look on the spectrum analyzer, you see on the right the symbols that are flying through the air. So how does the range work? Another key feature of LoRa is the receiver sensitivity. And that means that receivers don't need a very strong signal to actually demodulate the information. And that means that the sender can also use very little power to send data. So in this case, in EU, we are limited to 14 dBm. There is a receiver sensitivity, which is theoretically minus 137, but it's theoretical. And that means that if you see the range, you can calculate what the so-called link budget is. Now, I'm not going to go into too much technical detail here, but what is useful is to compare that to other wireless technologies. And Wi-Fi has a link budget of 95 dBm, unlicensed LP1, so that is LoRa has 151, And then licensed LP1, which is kind of the narrowband IoT technologies, has a bit of a higher link budget, but you also see that that is achieved by a higher transmission power. And that means that the end devices need more power to send, and you see the same in Wi-Fi. So what's really powerful about LoRa, about this unlicensed LP1, is that you are using ISM bands, but also that you have a really high link budget with very little transmit power. And less transmit power means more battery life. Using this formula in the bottom, you can calculate what the theoretical maximum range is of LoRa. And with US 915 regulations, the theoretical maximum is 850 kilometers. And that's a lot. And to see actually how LoRa performs in practice, Thomas, together with a few other community members, created a helium balloon and a very small sensor attached to it, and they let the balloon go. It flew from around Utrecht, that's in the center of the Netherlands on the map, to the German border, and somewhere above Germany, I think about 26 kilometers in altitude, something like that. It sent a message to one of the Things Network gateways in Poland, which is 702 kilometers away. And that's, of course, not a practical, useful test, but it shows actually the performance of LoRa. And then also the next question is often, so then you need only one gateway to cover Europe? Well, that's not, unfortunately, not entirely true. Also, Thomas is going to tell a few more things about that. The problem is you don't have free space. There is attenuation, reflection, diffraction, Fresnel zone. But still, the performance of LoRa is really good. Like Lucas said, in cities like these, with just a few gateways, you have citywide coverage, also indoor. So that's really powerful. So comparing to other technologies, what's also really important, LoRa is complementary to existing wireless technologies for IoT. So if you, just a very rough overview, range, bandwidth, you have near field communication, super low range, low bandwidth, perfect for contactless payments, tag scanning, Bluetooth low energy, wearables, headsets, things like that. Wi-Fi, smart home, smart office solutions, very powerful. Then on the right, you see the long range and low bandwidth technologies. And there's a narrowband IoT that's operated by telecom operators. Very useful for smart grid, high value object tracking, connected cars. It will probably use a bit more power, and you will always have some kind of subscription because it's a licensed spectrum. LoRa, on the other hand, is really useful for agriculture, lighting, low value object tracking, smart metering, utilities, basically everything, but you need to provide the coverage yourself or be part of a community to build coverage with you. So this is a little bit about LoRa, and when we learned about this in 2015, when we started, we thought, okay, we can build a LoRa network ourselves, together with the community. And so when Wienke found out about this technology on an IoT meetup in Amsterdam, where KPN presented this, we sat together and we thought, okay, we should do something with this and build a community network. So we formulated our mission to build an open, crowdsourced, decentralized IoT network that's owned and operated by its users. And the original idea was really to cover the city of Amsterdam, our city where we live, with just a bunch of gateways that were sponsored by companies that we used to work for, companies that we knew had a really good location, or companies that just wanted to be involved in some innovative network. And this was the original plan before we didn't know anything about actual LoRa performance. So we just drew a few circles on the map and we thought, okay, this should be a citywide network. And actually this worked. So we called about 10, 12 parties and we asked, hey, do you want to place a gateway? And most of them said yes. So we started in about 4 or 5 weeks with a network in Amsterdam. And we needed a prototype. And this is always the famous boat example in Amsterdam that is still relevant, because this is a really good use case for LoRa. And just a little bit of background: in Amsterdam you have a lot of these canals in the city and a lot of small boats, and they run water. And if you wanna put a sensor in your boat to see if your boat is underwater, then you can't use Wi-Fi because you don't know the Wi-Fi credentials around. You can't use BLE because the range is so short that if you're with your phone near, you might as well just look in the boat yourself. And in this case, LoRa is perfect. And also, you don't need to send any payload. Actually, the fact that the boat sent the message may already indicate that the water level sensor detected some water. So this is super simple. So we built our first use case around this, and this was actually the night before our launching conference in August. And this in Dutch says that your boat is underwater. And actually, I was super happy when I saw this on my phone and thought, okay, I should. This actually works. And then the next day, we had our launching conference in Amsterdam on a summer Friday. It was about 35 degrees in here, I think. And there were already a lot of people that were interested in the idea, because they already had an idea. Okay, this could be very interesting and potentially big. And this not only happened in Amsterdam, but also around the world, because what we did in Amsterdam was kind of a recipe for other cities and areas to do the same. So after Amsterdam, we got inquiries from all kinds of places all around the world, from Sydney, Buenos Aires, New York, very early initiators that started building a Things network in their city or area. In August last year, we celebrated our 3rd anniversary. And these numbers are already outdated because indeed we passed the 50,000 users. But it gives a good overview of the reach and what we achieved in only 3 years together with the communities, like here in Slovenia. And then a lot of people ask us, so what can you actually do with it? What is being done today on TTN? And to be honest, most of the use cases are quite boring. They are water level sensors in cities, waste bin collection. There are some funny use cases, but they're actually super serious, like the mouse trap from a pest control company that sends a message when it caught a mouse. But there are actually super inspiring use cases as well, like Finduino, which is a project from a guy in California, Rainier, who built this system originally to save water for wineries, and he achieved 30 to 50% reduction in water use, which is also super relevant for other wine areas, like for example in South Africa, where sometimes there's a water shortage. And the Things Network as a community, because it uses the same technology, also allows these projects, and this is also an open source project, to be used all around the world. Another thing is wildlife tracking. We've been working with Tim from the Internet of Life. Our technology today is not ready yet to be used there, but we are working on that so that in offline scenarios where there is no internet connection, you can set up an offline network to track rhinos, and that's apparently the only way to really protect them, to know where they are and to actually guard them. Another super inspiring project by Irnas is the green sea turtle tracking. Hopefully he's going to tell a little bit more about that today or later. But we also have business cases. So I'll tell a little bit more about our commercial activities as well later. But this is one of our customers, Deutsche Bahn in Germany, which is the second biggest transport company in the world. And they also embraced the Things Network, also the community aspect of it. and they placed TTN gateways on their stations. And one of their use cases is to synchronize the clocks. And it sounds super simple, but if you can do that wirelessly, and if you if you put a sensor in the clock, you don't need cables in the first place to synchronize them. But also when you start designing some electronics to put in the clock to synchronize them, you also create an opportunity for yourself to add more sensors to that clock. And clocks are everywhere. So a nice addition is to count people. And there are other community projects as well, but also commercial projects to listen for BLE and Wi-Fi signals and to turn that into an estimation of how many different devices there are. And that number can be sent over LoRa. It doesn't give you maybe the exact amount of people, but if you have this all around the station, you can get a very good insight in the relative crowdedness of the train station. We have various customers actually that are in cold chain, and that's essentially monitoring coolers and freezers for food that needs to stay cool. And these are very often indoor solutions, very often driven by private networks, because you really need coverage at a certain location, and sometimes you have big industrial freezers that are metal and you need somehow coverage inside. And the nice thing, and that's actually what I'm going to tell a little bit later about, is that these private networks for the cold chain, but also the private networks that are built by the Deutsche Bahn, for example, may actually exchange traffic with the community network to create one big network, just like we built the public network together. So the public network currently is operated by around, we are 7 regions now, public regions. We operate, the Things Network Foundation operates 4 of them. That's also where we started with, in EU, US, Brazil, Singapore, to provide low latency all around the world. It's one global network. If an application is registered in EU and the device is seen by a gateway in Singapore, and also that device adheres to that frequency plan, then the data actually goes all the way to the EU. It's really a global network. And in Switzerland, we have a very active community in Zurich, and also because Switzerland is not EU, they have a region, a Swiss region, that's operated by a non-profit association. In Australia, there's Meshed, which provides the public cluster for the Things network there. And finally, we have Digital Catapult in the UK that also provides a public cluster for the United Kingdom. And this is also something that we are extending. So we are currently having conversations with Poland, Russia, but also South Africa, Japan, China, India, to also build a cluster there. And it's basically to decentralize the network, to avoid that all traffic goes to certain servers, which improves the overall resilience of the network, but also is better for the latencies. And also it makes it less dependent on us, because operating 4 clusters with about 80% of the traffic is also quite a responsibility, which we love to do, but eventually for the Things network as a community is decentralized, the conference organization is decentralized, and we also want to actually decentralize the network itself. And our next version of our stack, V3, will actually support this model very well. So our stack, that's our software. That's what I spent most of my time on myself. It comprises of a few key components. So we have the gateway server, which is connecting the gateways itself, the LoRaWAN network server, joint server, application server, and the integrations. And integrations can be with IoT platforms. And the gateway server is monitoring the gateways and configuring the gateways. By the way, this is already the architecture of v3. v2 that's currently operational is also a bit similar to this, but v3 is way more advanced. Gateway server can remotely configure gateways, so we'll also make it possible, for example, to remotely switch gateways to a different region. So when we introduce a public cluster in Middle Europe, Central Europe, or in Eastern Europe, we could automatically change the gateways to use that cluster. Network server is LoRaWAN 1.0 and 1.1 compatible, and we also support all LoRaWAN regions. We have network operations, a console which is multi-tenant, and actually also a change from v2 is that we will make the console as well as the identity server open source. So the entire stack will be open source, available on GitHub. The join server is also, that's a new component in our architecture. It's the store of the root keys of the end devices. So this is where the secret keys are in that are required for the device to join the network. And this join server is also LoRaWAN 1.1 compliant, and that means that it can also be used with other networks. And our network also works with third-party join servers, because sometimes you see that certain end devices off the shelf are already configured on a certain join server, and our network can also handle that join procedure. The application server contains the session keys on the application level, and that means that the application server does the encryption and decryption of payload. And that's basically its most important role. It also does the encoding and decoding of payload, because you can imagine that the data that you send over LoRa is binary data, so it's just a bunch of bytes. And to make sense of that, the application server knows which device it is. It runs a little bit of code to decode that binary data into a sensible object. For example, saying the temperature here is 22.6 degrees. The application server is also a component that you can run yourself in your own infrastructure. So you can choose to use the Things Network public network server that's operated by us. And if you use your own application server, then we just route encrypted data to you, because you have the keys to decrypt the payload. So operating an application server is easy, it's open source, and you can you really control the security of your solution. Finally, we have integrations. Like I said, this is MQTT, HTTP, Node-RED, all software level SDKs, but we also provide integrations with the bigger cloud IoT platforms such as the Google Cloud, Azure, AWS. So this is a cluster, and this cluster can be deployed in different regions, but also in different ways. And later today, I am going to give a workshop, which is more like an interactive session about different deployment models and how you can leverage this cluster. Because sometimes this cluster, you want to run it as a public community network, but maybe you want to run the entire cluster on an embedded machine where you don't have any internet connection because you're somewhere on the ocean or in the desert. So a cluster can be deployed, for example, by the Things Network as a public network. And then here you have the gateways. But also the Things Industries, which is our commercial entity, also provides hosted clusters, private clusters, for which we also provide an SLA. Because that's also very often the question that we get is, so beautiful story, guys, but how do you make money? And our foundation is non-profit. Actually, we cover the costs for operating the public cluster, for LoRa Alliance membership, things like that. And next to the foundation, we built a business called the Things Industries because we wanted to make the entire initiative sustainable. So we need some source of income. And also because we receive quite some requests from companies that want to have their own network, private network, and they want to have an SLA, which we cannot provide on the public network. Also, there are some quite advanced additional features, enterprise features, integrations, firmware updates, multi-tenancy, auto-scaling, things like that, that are really designed for private networks. So this is hosted by the Things Industries, and what we are now working on is pairing between these private networks and the public network. And that means that the coverage of private networks is actually added to the coverage of the public network and the other way around. So we require, for pairing with the public network, we require contribution. So we require that private networks also contribute back to the public network. So we don't want private networks to operate without any gateways and just taking coverage from the community network. But they have to contribute back, and then we enable pairing. And the pairing allows for devices to be seen by gateways of the public network, community network, as well as private networks, and then the data will be routed through our pairing technology to the right network server where it will be handled. This could be a hosted solution in the cloud. It's our SaaS approach, for example. It can be on premises, so that's where we provide technology to install the entire stack on a server or using virtual machine images locally or in their own cloud. And if you have a message that comes from a gateway on the gateway server and that's meant for that cluster, then it stays there and it will not leave the cluster, and it will eventually be encrypted within that cluster. But you could also have a message that comes through a gateway connected to the public network in the Things network, public network server, and then the cluster is like, okay, this message is not for me, and it will offload it through our pairing bridge to the cluster that can actually handle that traffic, and that is where it arrives in the application server that has the keys to actually decrypt the payload. So this is provided by Things Industries. It can also be on site. Like I said, this cluster is entirely open source. So when we push this to GitHub, you can actually clone the repository yourself, build everything from source, and install it however you want. Also, we give access to pairing, but then again, we need to have some contribution to the foundation for address space as well as routing. So that's our story, and we always say you are the network, and with that we mean that you are the network by placing gateways, by contributing code to GitHub, so you can help us improve our technology, improve our SDKs, our documentation, things like that. You can also join a community or initiate a community yourself, come up with bright ideas, or provide even a very good location for a gateway if you have access to a building with a beautiful view. Or you can write some technical stories about how to build solutions on the Things Network Labs. And with that being said, my last slide is the announcement for the conference that you already heard.
Hi,
thank you.
Johan. Thank you.